So I'm here to talk tonight about lazy collections. And this is something that has existed in other languages in various forms for a long time, has been in Swift for a couple of years, and I forgot all about it, and I was reminded of it. And this is kind of how I was reminded of this feature that exists and like I have not ever used until a week ago. First of all, many of us have probably heard this quote often attributed to Larry Wall, the original creator of the Perl language, that there are three important traits of a programmer. We're supposed to be lazy and impatient and have hubris. And he spins these to all mean be sort of positive things, that they affect our work in a positive way. And the quality I want to talk about right now is laziness. And this also, I found this quote online, also attributed to him. You know, it's the internet, who knows who said this. But the quality that makes you go to great effort to reduce overall energy expenditure. It makes you write labor-saving programs that other people will find useful and document what you wrote so you don't have to answer so many questions about it. Hence the first great virtue of a programmer. And I think that all of us can recognize something of this because all of us know that we get to a point where you're doing things that you feel like, okay, I've done this too many times. It's not worth the effort to do it again this same way. I'm going to find a way to make this quicker for me, for my colleagues, for everyone who's asking about this thing. And this is kind of what spurred what I'm going to show you here tonight. Let me just maximize this. Can everyone see this? Is it big enough text? Okay. So I'm going to give you guys a completely constructed example because I don't want to show you like actual product stuff I'm working on, but imagine you have a system that has this person object and the person has a first name and last name. I've added a description so we can print it out nicely. It has a very complex operation it can do, encapsulated in this do some complex thing method, which either gives you some string back or it gives you nil. And at the bottom of this, I've constructed a list of people, a list of famous comedians in this that are all of this person type. Now, the code that I came across that spurred all of this was I was looking at a pull request from a colleague, and I saw something that kind of struck me as being a little bit too much. Now, again, this is not a person object. It was not the same thing exactly, but it was very much like this. There was a method that was going to return a value. It was going to return a value by looking through an array of things and finding, okay, all the things in this array, I know they could implement a method that's going to maybe return a thing or maybe return nil. So what it does, it says, okay, and so here in this case, I've made an extension on collection that's going to go through all of the people in this collection and say, okay, if I get a result of this do complex thing operation, I'm going to return that result. So you might have 1,000 things in this array, and maybe 900 of them actually implement this do complex thing or return a non-nil value. This will just return the first one and stop running. You don't want to go through every instance of this because you've already got one. All you want is one. So we'll try and do that, and if none of them actually implement this, if all of them return nil from this method, it will just return nil. And we know that all this method does in our case is it looks at the first name of the person. It says, is the first name Carol? If so, I'll return the last name. Now again, in my real world example, this method was doing a much more complex thing with potentially a lot of recursion and things that could be not fun things to call on a bunch of things in a bigger array. So anyway, let's see what happens when we run this. I'll just run this from here. So if I call this any match method, we can see over on the right that we get back Burnett. So it found one item in this array and returned the last name, which is Burnett. Now, again, as I was looking at this, I felt like this seems kind of long. This seems like something that I would want to do using a compact map. And I was thinking, okay, is there a compact map function that will exit after it finds exit after it finds some number of things? Like in the basic form, say we would do this in a naive way and not worry about performance. We could just do this. We can implement a connection or a method on collection called any match. Here it's called any match naive. It calls self compact map, and the transformation it applies to that is to call the do some complex thing method. And then at the end of it, it returns the first result of this. So again, if you have 1,000 things and they all return some non-nil value and they all take some time to compute it, this would run all of them over and over again. And all you want is the first one. So it's like, this is not what you want. So I started looking around. I couldn't find any sort of like compact map first method or anything. So I thought, all right, I'll just make my own. And so I did. And so I wrote my own method. I actually wrote two methods. There is one called compact map that takes a first parameter, which is a maximum number of things to find. And it does pretty much the same thing that we saw in the initial method, that it goes through all the elements and tries to apply this transform on all of them. The difference is that if it finds ones that actually return non-nil, it sticks them all into this results array. And at the end, it returns the results array. So you can call this method with a number and a block, and it will execute this block until it finds that number of things. And then as sort of syntactic sugar, I added a method called compact map first, which does the same thing. Well, it calls this method with a first value of 1, and then it just returns the first item off the end of the array. And so this also achieves the same result, of that it goes through this transformation on this mapping that you pass into it, and the first time anything is non-nil, it returns that one value, and it skips all the other times. And I thought this was kind of neat, and I put this up in a gist, and I posted it on Twitter, and I posted it to my company Slack. By the way, I work for Dynamo. I didn't mention that, but you can see it on my things and stuff. So I posted on the company Slack, where about 2 minutes later, my friend Edward said, "Isn't this just the lazy collection thing?" And I was like, that sounds familiar. What is that? And I realized that this is something that Apple does have some stuff around this in iOS and macOS that I just forgot. So this came out in about, I think it was either 2016 or 2017. And I don't know about you all, but I sometimes have this sort of like WWDC syndrome where they announce all these new things and I look at them and read about things and watch videos and think, that's really cool. I'll file that away until a year from now when I don't need to support the old version of everything. I think this is one of those things where I remember reading about this, the lazy collections, it seems really cool, and then I just forgot all about it. So with lazy collections, what you can do is you can take a collection of items, like an array of person objects, and you can do compact maps and filters and all sorts of things on them without actually all of the things being evaluated. It only evaluates enough that it needs to pull out the final thing at the end. And an example of this, then, is I'm going to show you, well, if I jump back to what was the naive version of this, that is not very optimized for performance, this self.compactMap with the block followed by .first. The lazy collection version of this is to say self.lazy.compactMap, the exact same thing. So the magic is all in this lazy. What this lazy does is it returns a new object that is a lazy collection, which wraps up your original collection. And what the lazy collection does then, when you call compact map, it gives you back another sort of lazy collection that wraps up this transformation you send it. So it doesn't actually execute what you're doing in that map until you need to pull values out of the resulting thing. So when this code is executed, it will actually not, like this first chunk of the line won't really do anything. If you assign this to a variable, that block is not going to be called one single time. It's only when you call .first, or if you call .count on it, or if you try and do a subscript on it to get out the third item or whatever you want to try and do. It's only when it needs to actually resolve into a concrete set of results that it actually begins to execute the blocks. And then what it will do in the case of say first is it will only call it once. Or if you do a subscript 3, it will execute it until it has enough to reach that subscript. So, and I didn't actually, I skipped through. I have all these commented out here. I'll just enable them and run them all. And you'll see that all these get the same result. All of these things give us Burnett at the end because they all work the same. I want to show you a little bit more of a way of sort of looking at some of this. Because once I started thinking about this, I felt like it was useful to kind of look at what actually happens in the various steps. So let's say we just assign people as it is to a thing called P1, and we can print this thing out. And if we take a look at this, we see that we have, this one. We see that we have this array containing all the names, and the names are used in the description method, so they're nicely formatted. Now let's look at something here. Here I'm going to take people using the regular compact map and do my same trick of of calling do some complex thing on it and then calling .first at the end. And this is going to go through all of the items. So when I hit run here, we can see here over on the right, it actually shows 4 times. So it's actually run this loop. Well, it's run it 3 times. There's always one extra for bookkeeping, I guess. So even though the first item it found is the one that matches what we need, it had to run through the entire array to find what it was looking for, because that's all that normal collections can do. Now let's take a look at something else. So I showed you what people looks like just by putting it out. If we do the same for people.lazy, we'll see something pretty interesting. I'm going to expand this here a bit. So this thing is no longer just a plain old array. It's a Swift lazy collection wrapping an array, wrapping my person object. And you see there in the oops, it disappeared now. Actually, I'll open it up there. I can't quite see it all. You sort of can. There we go. So in like the base, it contains the original array. It still hasn't really done anything with it. So it's like, hey, I'm this lazy thing that's going to allow you to do interesting things with this array. And in fact, if I try and look at the values of it, it won't even actually show me the values of what's in the lazy array, because its concern is thinking that, okay, I'm not going to worry about any values until I really need to worry about them. Okay. So now finally, if we get down to the end, we can see what happens when we do this sort of lazy compact map. The whole thing that I showed you that the sort of laziest version of this does. So we're doing this people.lazy.compact map, calling do some complex thing and doing first, and assigning that to P4. And as we see over on the right here, it shows that it executed it 2 times. Again, it went through the loop actually only once, but there's always an extra one for kind of bookkeeping, I guess. And it's giving us the same correct result, which is Burnett. And if we look at what the result of this P4 is here, well, actually, no, it is right there. There's nothing really to see there. But we can do one other thing that I didn't really think about before this. If I just actually take away this dot first, we can see again that it's actually going to, it's not going to really do the mapping if I run this. So what we had before, a lazy collection wrapping an array of things, now we have a lazy map collection wrapping a lazy filter collection, wrapping a lazy map collection, wrapping an array. And so it kind of gets pretty hairy internally, because for each sort of step you add to the chain, we can type lazy, and then you could do a compact map and a filter and then another map and all sorts of things. And all those things are just going to add to this bigger and bigger thing wrapping it up, that won't ever actually execute that block one single time until you try and do a lookup on it. If you try and look for a dot first, or do a subscript on it, or ask it for its count or whatever. So I think in retrospect, as I was doing this, I thought about sort of the thing of being a lazy programmer, and being a bit impatient, and having some hubris. And I think I kind of fell into all of these things, because I saw this thing taking up too much code, and I was like, okay, there's got to be a better way. I looked and looked and looked a bit, but I was too impatient with myself to actually find the actual lazy collection thing that Apple already had there. And so I wrote my own thing, and I put it in a gist, and I put it on Twitter, and it's like, ha, this is great. And then it's like, Edward again says, hey, you didn't need to do that. That already exists. So there my hubris got me. But anyway, that's pretty much it. It was just a short, sweet thing here I want to show you guys. And I hope that this is useful for some of you. And if there are any questions anyone has, feel free to contact me afterwards or look me up online. That's it.
So maybe we can take some questions right now, because we're kind of on time.
Plug back in case anybody.
So any questions for Jack? Daniel over here.
Thank you so much for this. I think this resembles the iQueryable thing in C#, which is like an executable graph that is executed as you question it. But what are the drawbacks of this if you build a really complex expression, for instance? When would this become like a performance trap, or what could the drawbacks be?
It's hard to say. I mean, I think that if in your actual code paths you're always dealing with very small arrays in reality, and you don't almost never have a problem of performance in general, like then maybe you can see that okay, like each one of these things is kind of building up a new object, wrapping other objects, or a new struct anyway. So yeah, maybe you can see that like we're building up this kind of like big onion of things, and maybe we didn't need to do it because sometimes all you're getting is, you know, maybe we had this thing where we're going through your array, your original array, and it's all the thing you're looking for is always the last one for whatever reason. Like you've done something weird in your code where it just happens that this array, the thing you always want is always the last thing. So it's going to walk the whole array anyway. In which case, in here, we're kind of building up these layers to no avail because we always have to go through it all anyway. But like but that's kind of that's kind of an edge case. In general, I think this seems like a really useful thing to do. Anytime that you don't want all the results, you want some subset that you're going to sort of grab out a few things. This can save you a lot of iterations.
Any more questions?
No.
Nope. Well then, thank you very much once again, Jack.
Thanks, everybody.